Assalamualaikum, madam. Today my group will be presenting our group assignment, which is will be presenting about Queen's theorem, and we will do some question. This is our group member. I myself is the first one, Muhammad Harisdanian bin Hasbullah. Okay, what is Green's theorem in general? So Green's theorem is basically we evaluate a line integral, but it is simplified by Green's theorem. So this is our formula here. The formula is uh, double integral partial g and minus partial f in terms of s and y, and then times with the derivative of area, where the dA, it can be polar coordinate or maybe xy ds dy. So the Green's theorem provides another way to calculate, where the catch is where C is a simple closed curve. There cannot be a open curve or maybe a hole in it. No, you cannot do that. So okay, this is our question. So we will do 4 questions. The first and second question is quite simple and direct, but it shows us the fundamental on using the Green's theorem. And then this is the third and the fourth question will be using final question set, if I'm not mistaken, is 2019/2020. Okay. I will presenting the first question.
Assalamualaikum, madam. This is our first question. So basically, it is quite direct. As our first question, okay, we will be using this formula. This is partial derivative. Okay. Evaluate integration c y square dx plus 3xy dy using Green's theorem. Given x and y here, our cos theta, our sin theta. Okay, basically our figure, we are given two semicircular half circle with equation x square plus y square equals to 9 and x square plus y square equals to 1. Okay, here it is counterclockwise as required in our Green's theorem. Okay, here I already done our solution to shorten our time. So therefore, we just substitute normally. So we just partial derivative here, partial derivative this, and we get 3y minus 2y dA. Okay, finally we got only y, and then from there dA is equals to r dr d theta. This is a polar coordinate. It is easier because this figure shows our polar coordinate. Okay, from this r region, we just substitute this equation, y equals 0, s equals 0. Therefore we got s equals 1, y equals 1. Same goes for here, this equation, y equals 0, s equals 0, s equals to 3, y equals to 3. So finally we get here, we just for the axis 1, 3, and then half a circle, therefore 0 to pi. So r sine here, we just substitute with y here, substitute in y with r sine theta, and then I just simply do the calculation, basic math calculation here, and then finally we get the value of 52/3. Okay.
Hi, I am Hidayat Ali. So for the next question, it is quite simple. So we can have a better understanding about the Green's theorem. For this question, we need to solve it based on the given vector and coordinates. So we can make a graph based on the information given. This is a graph, and the value of dx we can obtain by going through left to right. Meanwhile, for dy from downwards and above. For the solution, we can use the Green's theorem formula at the upper right corner, so we can apply it on the question, and we obtain this solution. For calculation, we got integration of dx by this, integration of y by this, and firstly we solve the integration of y, and we got this, and we solve for integration of x, and simplified mathematics, we can get the final solution as 32. I hope it will help you for a better understanding about Green's theorem. That's all. Thank you.
So, Assalamualaikum. So today I, Muhammad Fikri bin Aziman, will explain on how to solve a question using Green's theorem. So today I will explain how to solve on question 3a1. So from this equation we need to solve it using Green's theorem, where C is the triangle vertices 0, 0, 1, 0 and 1, 3, which is positively oriented. So firstly, we need to draw the graph for the bounded region. So from the equation we get a triangle shape, plotting using the coordinate that were given. So firstly, so next what we need to do is we will separate it to the P part and the Q part, where P is equal to 1 plus x cubed to the power of 1 over 2. Q is equal to 2xy. So when we differentiate it using the formula, we get the P part we will get to equal to 0, because there is no Q indication. Where differentiate for the Q part, we will get to y when we refer to the x. So next, to find the limit for the y part, we need to find the gradient first. The gradient for the line from 0, 0 until 1, 3. So we need to find the gradient. So we get the gradient is 3, and because it is intercept on 0, 0, so the equation is y equal to 3x. So next what we need to do is we substitute it like the formula. So we will get the limit part for the y is 0 until 3x, where the x part is 0 until 1. So when we integrate the y part, we will get 2y square over 2. So we simplify it and we will get y square. And we substitute it with the value of 3x and 0, and we will subtract it, and we will get 9x square. And again we will integrate it, and we will get 9x cubed over 3. And we simplify it we simplify it, and we will get 3x cubed. So like the above, we will substitute it with 1 and 0, and we will subtract it, and we will get 3. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh, and a very good morning to you guys. Today I'm going to teach you about Green's theorem. So okay, my name is Mio Muhammad Nasri Firdaus bin Fazil. Okay, this question is taken from set final 1920, and it's question number 3, part 2. Okay, now this is the question given, the equation that given in the question. So this one is the equation, and this is the C boundary here. Okay, this one is the boundary. Okay, now after we get the equation, we need to sketch it first before we do the integral. Okay, now here we have the sketching. So this one is the quadratic, where x equals to y square and y equals to x square, where this one from this one. So we need to sketch the quadratic is u. So it's from y equals to x square is this one, and x equals to y square is this one. Okay, so we get the parabola. Okay, now the Green's theorem is counterclockwise. So the formulas that given in the Green's theorem is this one, p dx plus q dx, and it's equal to integral r dq over dx minus dp over dy dA. Okay, so what we need to do is we need to have this p and have this q. So where to get the p and where to get the q is from the equation that's given. Okay, so here this part is p and this part is q. Okay, so now we need to integrate it. Not integrate, we need to differentiate it. Okay, differentiate it as a partial derivative. So dq over dx is from dq is this one, so it has 2x and cos y. So partial is c over dx 2x, and this one is c over dx cos y squared. Okay, so what is have here? So here have x, so we interested in x. So here is going to be 2, and this part don't have the x, so it's going to be 0. So the answer is 2. And this one is p, so dp over dy. So we're going to be interested in y. So here is p, y exponent x. Okay, so now dy y here become 1 plus this one don't have the y, okay, it becomes 0. So now we have 2 and 1. Okay, what we need to do now is we need to put this thing into the equation here. Okay, so here is the equation. So we need to have the integral r. So we need to have the limit. Okay, the limit here we need to find is this one is dy dx. So from down to up and from left to right. Okay, so now what we need to do is we need to find the limit here. So we get x squared to square root x, where this one is from down to up. We're going to meet this line first. So this line is y equal to x squared. So we need to find for y x equal to square root. X is square root, and then go to the upper line. Upper line is x equal to y squared, where we need to change it into a y term. So it's going to be y equal to square root x. Okay. So this one we already get it. So x squared to square root x, and now the x limit is from 0 to 1, where 0 to 1 here. Okay. So now what we need to do is this one 2 minus 1 is where we get from dq over dx minus dp over dx before. So we get 2 and 1. So we just need to 2 minus 1 and we get 1, and then integrate to y. So we get y, and then we just input it into here. So square root x minus x squared, and now we just need to integrate for x limit, where this one is it have a dx here, and then after that you get the answer. So the 0 here just need to do just put it into the calculator and you get the final answer. That's all. Thank you.